Educational GMAT. Your partner in your GMAT journey.
These are important concepts.
All right. It's a question.
So question will be, I think, on the next slide. This is the data that is presented.
All right.
So I also want to take this question to explain to you how percentiles need to be interpreted, Shivant. So please go through this.
All right, Red. It's a typical statistic sort of a question.
Correct. So I'll just explain to you what it means.
Yeah, please.
All right. So what it basically saying is, notice at the age of 2 years and 0 months, 81.4 centimeter is the third percentile. 83.9 is the 15th percentile. 87.1 is the 50th percentile, and so on.
The
What does
lowest
it mean
height
by
81.4 centimeters and the highest being 92.9.
sorry?
So basically, the lowest height being 81.4.
Now, that's not lowest, by the way. This is, so let's actually start with 97th percentile. What does it mean? What it means is, Shivan, that for a child of 2 years of age, if that child's height is 92.9 centimeter,
Yeah, he falls in the 97th.
that child is in the 97th percentile.
Yeah.
For his age in terms of height. What does it mean? That this height, a child with this height, 92.9, is in the 97th percentile, which means only three, very nice, only 3% children have a height of more than 92.9 centimeters at 2 years of age. Are we clear?
Yeah, yeah.
Similarly, let's take one more for clarity. Let's take this one. What does it mean? No, let's take this one. What does it mean? That a child who is 4 years and 6 months, if that child has a height of 111.2 centimeters, it means that he is in the 85th percentile. What does it mean by 85th percentile? Only 15% children have a height of more than 111.2 centimeters for this age.
Yeah.
And this exact statistic is also represented in terms of this graph. Exact same. While these lines are representing various percentiles. Notice third, 15th, 5th, notice third, 15th, 50th, 85th, and 97th.
Yeah.
All right. Okay. Now these were the two graphs. Now look at this. Consider an individual boy from a model population. Notice this is the model population. Suppose that from age 2 through age 5, notice age 2 through age 5, this boy's weight is in the 97th percentile. This boy's weight is in the 97. Mind you, we are not talking about height in the 97th percentile. We are talking about weight is in the 97th percentile. Weight in the 97th percentile. So we are talking about this one, this particular line, right? Weight in the 97th percentile. And his height, now we are coming to height. Height is in the 97th percentile for his age. Height is this one in the 97th
Yeah.
percentile for his age. Which of the following statements must be true of the boy at the age of 5 years and 0 months? And the point is, and this is what I want you to understand, Shivang, that given these, notice, for example, what is given to us? Weight is 97th percentile for his age. What is B saying? Weight is, notice, weight is at the 97th percentile for his height, sorry. Weight
Hmm.
is 97th percentile for his height. So we cannot conclude that height is at the 97th percentile for his weight. In fact, none of these three can be concluded. So you cannot draw a correlation. That's the point I'm saying. If X is in the 97th percentile for Y, if Y is in the 97th percentile for Z, you cannot conclude that X is in the 99th percentile, 97th percentile of Z. You cannot conclude that Y is in the 97th percentile of X. So all these correlations are not allowed when it comes to percentile. So all these would be incorrect conclusions from the data given to us.
All right.
Are we clear, Shivan?
Yeah.
This is very important. A very simple concept, as I said, again reiterating so that it becomes clear. X is in the 97th percentile of Y. Y is in the 97th percentile of Z. If this is given to you, from this we can conclude nothing. We cannot conclude that X is in the 97th percentile of Z. We cannot conclude that Y is in the 97th percentile of X. We cannot conclude that Z is in the 97th percentile of Y. None of these can be concluded.